So what we found so far is we've got an alternator not charging. We're only producing 11 volts. We've bypassed the alternator battery charger, ran some direct cabling, and we're still only producing 11 volts. It's a self-exciting alternator, it doesn't need a warning light, so it ain't charging. So what we propose at the minute and what we found in here is we've got an alternator to battery charging device, which at the minute is connected to a lithium battery bank via this cable, which it's not designed to do. The manual and Sterling quite clearly depict that these units are not compatible with lithium, and they need a regulated charger between them, so a DC to DC charger. We've also found with the wiring in here, we've got some cable loops. So we've got a cable that runs to the house through the house isolator to a Class T fuse, which has been bypassed, and it's all joined on the same side, which then goes through what I believe is an old split charging relay, comes up to a jointing box, to another jointing box, and back to the battery. So that is just one cable loop that's not required. We've got isolators that are functioning. We've got a chassis isolator and a house isolator. Again, the house isolator shouldn't be here. It should be through a DC to DC charger and the isolator at the other side. We've got what I believe is incorrect size cabling from the alternator, which is 35mm square, I believe, looking at it, which drops up to 50. And that is, in my opinion, too small. It should be at least 50mm square to carry the current over the distance it needs to. What else have we got in here? Yeah, we've got quite a lot of negatives and positives taken from each battery bank, which again is schematically incorrect. They should all be taken from one side of each battery bank. So what I propose is we strip the cabling out, we identify the main factors we need, which is we need the generator cables to run to the generator so that can start. We need an alternator or starter motor cabling, depending which way the vehicle's wired from factory. And then we need a cable between the batteries to a DC to DC charger, which then runs through to the lithium battery bank. And what that will do is it'll remove all the unnecessary cables that are in here and make it a lot more simple and neater to understand. And obviously mark and identify what cables are required in the engine bay. And I propose potentially, because the alternator's not been charging, that we replace these batteries either with two of the same, slightly higher capacity, or one larger truck style battery that'll give you more capacity and better cranking for the engine as well.
So these are the ones from the original engine bay that feed the lithium. So you've got a positive, a negative, and then that's your house bank, which is obviously the original vehicle wiring, which is just jointed temporarily to give you power from your batteries before it's relocated.
And these are the doubled up cables.
They're the ones that are supposed to be doubled up to allow the extra current capacity, because that cable's not big enough to carry the load needed.
So what kind of diameter are these cables?
50mm square. It's identified on here somewhere. 50mm square.
Okay, that's
a little bit hard to read.
I will take a photo of that, but I think the video should get it as well.
And there should be a minimum of 70.
And they're all three are 50mm?
Yeah, I believe so. This one's not actually marked to say what it is, but it does look like it could be something around 50mm square. And this is the red.
Again, unmarked.
No, it will be marked there. Look.
Okay.
That's 50mm.
I'll get photos of that,
and that should be 70 minimum of. And the house cable's irrelevant in this case, because that is just the factory lead to the house.
Factory lead to the house. And these cables that are doubled up, there's two red and one black.
Yeah.
But there should be
two red and two black.
Two red and two black. Okay. This is this Sterling box. This is the B2B box.
Yep.
This is the DC to DC or battery to battery charger.
Which should have 70mm square cable fitted between it.
According to Sterling.
Yeah.
And that cable, which I'm just zooming in on, at the bottom that feeds to it, there's two red cables going in it.
Yeah.
What are they?
They're one from each. It appears to be one from each different lithium battery bank, and they are 35mm square cable.
35mm, is that written on it?
Yeah, you can see that just here.
The camera probably won't focus, but I will take photos of that.
And then there's where they come out of the isolators, the breakers, they go underneath, and you can see it's 35mm square rating on that as well. Yeah, so what we found as well is when we were just pulling on these cables yesterday while we were trying to find out what they were, the terminals are all loose on the isolator.
So okay, down that side there we can see.
They're literally all loose and not tight on any of them. So all that is going to do, when we can turn those cables around, which is not right, they're not tight and secure. All that's going to do is add to resistance and heat, which potentially could melt the plastic housings of them, which again is part of the quality of this setup, the questionable quality of them. We're fully aware of them being a fire hazard in certain incidents we've had in the past, where we've had to remove them for other customers, and there's quite a lot of investigative reports online about the quality of them. We'd never recommend fitting those isolators in any systems. They'd always be replaced with a fuse instead.
And there's 2 there, and also 2
for
on
the solar
the
side. Yeah.
other side.
Which I've not checked if these wiring is loose. Yeah, that wire is loose and it is moving on the terminal. That one is tight. That one is tight. And yeah, I think we can tighten that terminal up. That's not a problem. But the crimp there, we can see how easy that crimp is bending there. That's not crimped properly either. But yeah, those 2 are loose on that bottom isolator. So we'll get them sorted for you.
They need re-looking at because they're essentially not safe.
Yeah.
This is the electrical bay from the other side, and here are the lithium batteries, household consumer unit, and this is Combi 3, the inverter. But these are the lithium batteries, and there are 2 types fitted, 2 different sizes.
Yep.
So ones at the front just visually look longer.
Yeah,
and
there's
the ones
2 at the back
and there's
of the same of those.
2 at the back through there.
Yeah.
But this is all the wiring, or the nest of spaghetti wires across the top. And then these 3 batteries at the front have wooden underneath, piece of wood at the how high would you say that is there?
That is 1.5 inches,
About an
I would
inch and a
think.
half.
Yep.
And then the batteries
Are all loose.
are all loose.
They can just move freely in and out of there, pulling on all the cables. And there's not a lot of force required just to pull that out, and it pulls the whole bank out, which again, and all the batteries are rubbing against each other here. These ones, not so much because they have the foam pad in between them, but when they're moving in and out, it is just pulling the foam in and out. And obviously that will happen going around a corner. The other concerns I've got in here are, if we look at the top of the battery terminals,
Which we're going to try and put
which
the light on.
are on here, is you can see there's a wedge on the left hand side over here.
Okay.
You've got a wedge about 1 inch worth of washers on each terminal, and that happens all the way across a lot of the terminals. Now, best practice on these sorts of terminals is to have as little cable and terminals on each post as possible. And as you can see, across the whole battery bank, there are multiple terminals everywhere. What we've also got, again, is the wiring practices are not best practice. You have positive and negatives going to each side of battery banks, and then power taken out of the middle. So like this battery, for instance, here with these 2 cables, that's in the wrong place. The positive and negatives are out of the middle of the array and not either end, so it's not right in practice. There's a lot of parallel wiring that doesn't appear to be right, but until we pull the batteries out to do that, we can't document that thoroughly just yet. But yeah, the fact is they've got 2 longer bolts in there that have just been spaced out with washers is not great.
And that's on both sides of the terminals.
It's on all the battery banks, yeah.
On all the battery banks.
Yeah.
Okay. And I think you mentioned that the way the at least one of the battery banks has been wired, the power's sort of all coming from one battery as opposed to all of them, or something of that nature?
Yeah, the way it appears to be at the moment is the battery banks aren't being balanced, charged and discharged. They're being put into one side, so you have all your power and takeoffs and earths from one battery, as opposed to being split across the battery bank, which again is not best practice, because the batteries won't charge properly and won't balance right. And even though they've got their own BMS inside, they still won't balance right, because power's only at one end of the battery bank, not across the whole battery bank like it should be.
So essentially over time you'd end up wearing out one battery rather than all of them equally, type thing?
Not with the lithium, no. It's just you're not going to have the full capacity in the right place, so to speak, and you'll end up with different amounts of capacity left in each battery. And what we've got here as well is on the cable that is running from the Sterling, which is already incorrect size, we have what appears to be a very bad crimp here. That cable should not be able to be moved like that. The copper is not attached in that terminal properly, and that is just on this one lead here. It should not be able to bend round on itself as such.
This is one of the lithium batteries that you've pulled out, yeah?
Yeah. And this is one of the link leads that we've taken out, that are joining all the batteries together at the moment. Okay. What we found is the 10mm holes on there, so the right size cable entry lug, but the wrong size eyelet. So what that does, in essence, is when that is required to go onto an 8mm hole with an 8mm bolt, the bolt is too long, but that can move around in many different ways. And what that should have been, it should have been an 8mm eyelet in there, which you can see is now the same size. You put the bolt back in, and that eyelet has very little movement against that nut, so that actually creates a much better connection, and you're not just relying on the surface area at the bottom for connection, you're actually transferring it all the way through the bolt and the clamping force that's on there, which is what should have been fitted. Because they had too many connections onto a lot of the batteries, what they've had to do, and this is not the full example because these are just ones we've taken off one side, is they've stacked up washers on top of the bolt to reduce the distance that's left here, because this terminal would have had 2 or 3 terminals stacked above it to go down to clamp, which is how they've combated having too longer equipment installed.
This is Rachel's panel, so that's Combi 1 and 2.
So we're just going to go in and we're just going to look at the programming options we've got on here to see what the charging programs are set to, which is in group D, charger. So obviously charging curve adaptive and safe, which is incorrect for lithium. It should just be a fixed charging curve. Equalization, again, not required on lithium. Stop after 10-hour bulk if the batteries need more than a 10-hour charge time. That will stop that, and that's not the case with lithium. Charge current 80 amps, if that's what this inverter is capable of, that's all it can be. Float voltage of 14 volts. Lithium batteries technically don't need floating, but generally good practice to set them around about 13.5 volts. 14 volts is far too high for a float voltage. Absorption time, 4 hours. Lithium batteries, they're recommended, most manufacturers recommend half an hour absorption per 100 amp hour. So for instance, this one's 1200 amp hour capacity, so 30 minutes for every 100 amp of that, it'd be a 6-hour absorption time. It's set to 4. Repeated absorption days not required, because it'll be on and off charge anyway. Repeat absorption hours again, 4, incorrect. You've got an absorption voltage of 14.8 volts. Now the battery's specification that we found out is the absorption voltage should be 14.6 volts plus or minus 0.1 of a volt, so the maximum it should ever be is 14.7, and we'd always recommend between 14.4 and 14.6 as to not overcharge the lithium cells. Obviously that is too high. Battery type is user defined, because I don't believe this inverter has a lithium base profile. And then what we've got up here, we've got the same options on Craig's
So this is Combi 3.
This is your inverter, Craig, and I'm going to the programming, go through group D again. And we've got adaptive and safe incorrect, equalization mode enabled wrong, 10-hour bulk again, not in this case because of the capacity, 40 amp charge current, 14 flow voltage wrong, 4 hours again wrong, 28 days, 4 hours, 14.8 volts again, shouldn't be that high. User defined, again, no lithium battery type. So those settings do need changing to match the batteries properly.